Hello students, in this lecture, we will talk about some basic concepts of statistics. We will also talk about range, IQR and standard deviation using R. We will talk about certain descriptive statistics, central limit theorem demonstration, functions for normal distribution like R norm, P norm, Q norm, D norm, functions for binomial distribution like R binorm, P binorm, Q binorm, and D binorm. Binomial distribution using visualize package and certain Poisson functions like R poise, P poise, Q poise, D poise, and some more visualized packages. So mainly this lecture is all about start to statistics, that how can we use statistics in R programming, and we can use the robust functions in R and do the statistical analysis. So students, let's start from the very first function, which is mean. As we all know that the function mean is used to calculate in R, it is basically for averaging. We all have used the average function in MS Excel, and we know that in MS Excel, average is used to find out the average. Now, in this function mean, we are basically dealing with a list of values. We know that the list of values is an input vector, which is X. Here you can see that mean function is having three parameters, which are the main parameters. The first one is X, which is input vector. The second one is trim, which is used to drop some observations from both the ends of the sorted vector. Now, when I say trim, it means that from the left-hand side or from the right-hand side, I can drop certain values. Why I'm dropping? Because sometimes I have to trim the values which are on both the sides. And sometimes we use this function because we have to change the confidence level. Sometimes I have a data and I have to change the confidence level from 99% to, let's say, 95%. So in that case, I am reducing from both the sides. I'm dropping certain observations because I am reducing my confidence level. Now, there is a property na.rm. na.rm is used to remove the missing values from the input vector. So basically, when I use na.rm equals to false, it is the by default value. Let's have a look of the code now. We are creating a vector. The vector is having the values C with the help of C function, having values 12, 7, 3, 4.2, 18, 2, 54, minus 21, 8, and minus 5. Now, how will I find out the mean? It is very simple. I have called the function mean, and within the function mean, I am passing the vector x. You can see that the value of x is passed to the function mean, and the vector, which is x, is finally created, resulting the mean value in the variable result.mean. You can see that at the end of the slide, at the end of the last line, I am printing result.mean. So you can see that the output is 8.22, which you can see on the right hand side. So student, this is the very first statistical function which can be applied on a vector, and very easily we can find out the mean value. Now let's have a look of the trim option in details. What is a trim? Basically, when trim parameter is supplied, the values in the vector get sorted, and then the required number of observations are dropped from calculating the mean. So mainly, if I'm applying the trim function, in that case, my vector will be automatically sorted, and the observations from the left and the right hand side will be dropped. So when the trim is equal to 0.3, three values from each end will be dropped from the calculations to find the mean. So basically, if it is 0.3, three values from left and right will be dropped. So in this case, the sorted vector is minus 21, minus 5, 2, 3, 4.2, 7, 8, 12, 18, and 54. So you can see from the data that from the left hand side, three values, and from the right hand side, three values are in black color. So basically, the values which are removed are minus 21, minus 5, and 2 from the left hand side, and 12, 18, 54 from the right hand side. So what is left with us? We are left with 3, 4.2, 7, and 8. So now you can understand that the actual mean function will be applied only on 3, 4.2, 7, and 8, and the mean will be calculated for these four values. Now you can see the code. The code is having the vector where I have the values 12, 7, 3, 4.2, 18, 2, 54, -21, 8, and -5. So this was my vector. Now, when I'm finding the mean, in that case, you can see how I've called the mean function. There is mean function. Within brackets, I have passed the variable x. You can see x is my vector, which is the list of numbers. After that, I put a comma and I write trim equals to 0.3, which means that I'm dropping 3 values from the start and 3 values from the end. And now you can see that I'm finally printing result.mean on the screen. So you can see the output is 5.55. Now, when I'm finding out the total of 3 plus 4.2 plus 7 plus 8 and divided by 4, then I get the mean, which is 5.55. So students, I hope you are able to understand the concept of trim, that how we apply the trim function, the trim property in the mean function, and we can trim the values from left hand side and right hand side of any of the vectors. Next, we have applying NA operation. Now, NA operation is basically an operation which returns not available. So the idea of NA is that if suppose there is a value which is not available in the list of values, then what to do for that value? So in that case, I have two options. Either I remove NA from my data or I keep NA in my data and print the results. So if there are missing values, then the mean function returns NA. So basically, if there is a missing value, then the mean function will return NA. So to drop the missing values from the calculation, we use na.rm equals to true. So by default, na.rm is always false. It is by default false. But if I want to remove the na values, in that case, I will make na.rm equals to true, which means not available dot remove is equal to true, which means remove the not available values. Now have a look of the code. Create a vector. We create a vector where we have 12, 7, 3, 4.2, 18, 2, 54, -21, 8, -5, and NA. So here you can see that the mean is what? Mean, and within brackets we pass the vector. Now we pass the vector and we find out the mean in the variable result.mean. Result.mean is printed on the screen, and then again we find the mean dropping the NA values. So you can see the difference that in the first mean calling function, I have just passed the x variable and the result is NA. Why it is NA? Because NA is included in the list, so nothing was calculated. But when I am passing mean with x and na.rm equals to true, which is the second command for calculation of result.mean, we find that we get a value 8.22 as output. So mainly we can see that if I apply na.rm, automatically the NA is removed and the remaining values are considered, and for that the average or mean is calculated. Now let's talk about median. The middlemost value in a data series is called median. We all know that median is actually the mid value of a data set. Now consider a data set where there are lot of values and lot of outliers are there. Outliers means exceptional cases. So if there are a lot of exceptional cases, in that case, is mean a good indicator? No, mean is not a good indicator, because mean is not giving the realistic mean of the data set, because there are a lot of exceptional cases and lot of outliers which are either raising the mean or dropping the mean. So in that case, the best tool to use is median. Median is a tool where we sequentially arrange the data and then we try to find out the middle value, which means what value exists at the midpoint. Now, what is the advantage of median? That if I'm introspecting my data and I find out that if suppose there are 100 values and the middle value is 80, which means I understand that 50% of the values are below 80 and 50% of the values are above 80. So that is how we understand the data. So mainly, if I want to find out the median function, median with the help in the R programming, I will write median within brackets the variable x and na.rm equals to false. So you can see over here that na.rm is equal to false. So now I'm using the parameters x, which is input vector. Again, it is same as mean. na.rm is used to remove the missing values from the input vector. So you can see na.rm, by default it is false. If I want to remove the not available values, in that case, I will make it true. There are cases when sometimes I have to even project the answer that not available, because I don't want to perform a calculation after removing the not available values, because that data of that person which is missing is very crucial for final decision making. And that is why it is up to us whether we keep na.rm equals to false or true. So let's have a look on the code. First, we create the vector. In the vector, we are assigning a variable x with a vector where the values are 12, 7, 3, 4.2, 18, 2, 54, minus 21, 8, minus 5. Now here, median is calculated by passing x in the median function, and we are printing median.result. So we see over here the result is 5.6, which is the median value. So it is very simple. You can see that the entire data has been arranged in the ascending order, and after arranging in the ascending order, the middle value is calculated. And if there are two middle values, then the average of the middle value is found, and that is returned as the median value. So students, basically median is a function to find out the mid value or what value exists in our data series at the 50th percent location. We sometimes call median the 50th percentile.